Hi, if you're interested in my detailed training videos in course format, do visit my profile on udemy.com. The link to the same is in this video description. If you live in India or willing to pay by Indian rupees for my paid training courses, you also have the option to enroll on /prog.com. The link to the same is also in this video description. Hi, in this video, I will teach you how permissions apply to files and folders and what does read, write, and execute mean for a file and also for a folder. For a file, it might look a little obvious, but I will just demonstrate it again here. So let's say I've logged in as Alice in one of the terminals and I've logged in as Bob in another terminal on my Linux system, which is the Windows subsystem for Linux running on Ubuntu. So here on as a user called Alice, I'm in my home directory for now because I want to share files between Alice and Bob. I want to go to the temp folder. I'll say cd/temp. I cleaned up the temp. I think I have this folder called Alice. Let me go to this temp/Alice, which I created already. So you can see that folder. Anyways, in here, it shows the owner is Alice for the current directory, right? So let me just go and create some files here. So first, let me just create a file by using a nano editor. Let's say nano.a.txt, and this is a test file created by Alice, right? And this is another line also added by Alice. So 2 lines data in a text file. I just save this file, exit. You can see that there's a file called a.txt, and the default permissions for the file, maybe based on the umask setting, is 022. So when I see 022, that means for a file, execute bits are anyway turned off. The 0 here indicates read write for user, 0 here indicates read write for group, and 2 here indicates only read for others, right? This is how I can quickly translate from umask to the actual permission bits here. Reverse bit mask, right? I told you that when I talked about the umask command in the earlier video. So anyways, coming back here, this is the default permissions for this file, which also means that user called Alice can read from this file, and people who are owner of the group can also read from this file. It belongs to a group called Alice. Looks like nobody else will belong to a group called Alice. It's a private group for Alice. No other users will be in Alice group by default until you explicitly add them, which is generally not done. That's the whole purpose of user private group, and others have only read permission. So if you look at Bob here, Bob falls in this domain. I mean, these are levels, right? You can look at the user is Bob, the primary group ID is Bob, and the list of groups that Bob belongs to are Bob users, engineering, and support, right? If you're all for summary, you can use ID minus capital G to get a list of group members that Bob belongs to. If you want to look up the names, use ID minus capital GN. It lists both the primary group and the supplementary groups and use a capital G switch, right? By the way, so these are all the groups that Bob belongs to. This process running as Bob belongs to, right? And at this moment, if a user called Bob tries to access this file by traversing to /temp/Alice and looks up in here, this file is there. Bob can see this file. You can see that. But can Bob modify this file? Let me just see if Bob can maybe edit this file using the editor. Let's say Bob nano.a.txt as user called Bob. As you can see over here, file a.txt is unwritable. Nano sort of complains it, which means if you make any modifications to this file, you cannot save it. See, error while writing file a.txt, permission denied. So you cannot really modify the file. Why? Because Bob user, if you just see, I use only ID minus N. Minus N will work only when you pass the actual IDs, let's say ID minus UN, ID minus capital G. You can see that Bob is not the owner of this file a.txt, and because Bob is Bob, right? Is the user that is there, and Bob does not belong to a group called Alice. Therefore, group permissions and user permissions are not applicable. These have write bits enabled, but others only have read bits enabled. So Bob can read from the file but cannot write to it. Suppose if I remove the write permissions, if I do a chmod minus, I can say O minus R. From others, revoke read permission from a.txt. As user called Bob, to false in others domain, others level in here, you cannot even see the file contents this moment. If you want to allow somebody to write to your file, write to a file, that means you can also overwrite or append, you need to enable write permission. Suppose I do a chmod o plus w a.txt here. This time it's a little peculiar. The permissions looks a little peculiar. Others are write permission but no read permission. What this really means is, as user called Bob, you cannot do cat a.txt. That's ruled out. Which means you cannot use an editor to edit this file, because editors generally try to read the file contents to show you the data, and read is not allowed, so you cannot really read the file contents. So let me exit the editor. But however, if at all I try to modify the file manually, by one thing I can do is I can use echo, and this line was added by Bob. I'll use double greater than. I would have covered what this is in redirections and pipes when I talk about in that chapter. If you have not gone through it, just go through it. This will append a new line to a file without modifying the existing contents, right? So I say double greater than, and if I provide a.txt, this does not cause a problem, no errors, it worked. Bob can still not see what is there in it. He can write to the file, but he cannot read it. But as Alice, what changes are made, you can see those changes. This line was added by Bob. You can see that the last line in here. As user called Bob, you can also overwrite the file, because write permissions to a file allows you to append new lines to a file, but you can also completely overwrite the file and change it completely. So if Bob user tries to do a echo, this is a line added by Bob again. This time I use a single greater than a.txt. This will overwrite an existing file if the file already exists with new data, which is what this echo command is. The command's output is redirected to the file. If the file had any data, that will be fully truncated and overwritten. And this works without a problem. You can actually now verify as user called Alice, the old data is lost. So as a user called Bob, you can open the file for write mode and start writing to it. Or you can open the file in write plus append mode and start appending to the file. But you cannot read what you wrote. You cannot read any existing data from the file, because there is no read permissions for others that Bob belongs to, or the levels for this file, right? So something that you know. So you know the use of read and use of write permission. So if you want to really edit a file where you can see the contents and make some changes, you need to have read-write permission. So you might ask me, is there any valid use case for only enabling write permission without read? Rare scenarios for files, maybe logs. So if you're paranoid about security, like say, for example, you're running a service, some kind of a background service, and this service is running as a process in a particular user credential, as a particular user. That process is running as some user. And that process wants to write to a log file. But you don't trust that process. If the process could be somewhat, sabotaged or compromised to truncate a log file. That can be dangerous in some cases, because logs are very important. So you will only enable write permission for the log, no read permission. This way, that service cannot read from the log file, but only can write to it. Maybe append new entries in log. Maybe it cannot read. It can truncate the log if it can, but it cannot read from it. It cannot steal data, right? Maybe you can clear the log file. You can write some data, but you cannot read any data back. So that's the whole point. There are rare scenarios where you might need only write permissions and no read. But in most cases, if you imply write, if you enable write permissions for a level, you imply read permission also to make it more convenient, to make it more editable, right? So it's very rare to use only write permission. Very, very rare scenario when you are looking at paranoia and security. That's where you use it. When you look at that level of security, mostly you use some other security models to manage things better. That this is what you have. So now, having said this, if at all I want to, enable execute permissions for the file, I can do that. Execute permission makes sense if the program is executable script or a binary program. Let me create a script here. Let's create a script called, test script dot sh. Let's create a shell script. Okay, nano, sorry. I'm always tempted to use Vim. Then the first two characters must be the script signature for any script executables, and followed by the path to the script interpreter. In this case, I want to use /bin/bash as an interpreter for the script, followed by a simple echo message. I can just say echo this. I can say hello world from a bash script. You can also add another echo and say this script is running as process ID, and I put a dollar dollar. Dollar dollar will expand to the current process PID. So I'm just going to put that there. That's it. Nothing more. I'll just save the script and exit. Just two echo commands in the shell script. So if you do a cat test script.sh, there's just two echo commands in here. Whenever you create any file in a text editor, the file will not have execute permission, as you can see here right here. Which means in order to run this script, you have to explicitly type bash test script.sh like this. This is how you run it. You cannot say /test script.sh and execute them from the current directory. It will not work. It throws an error, permission denied. Simply because the user, group, and others, all three levels have no execute permissions. So if you want to enable execute permissions on this script, all you need to do is you do a chmod. You can do a +X here. Execute for user, group, others, right? All three levels, and test script.sh. Now run this command. You can see that this file is enabled with execute bit for user, execute bit for group, execute bit for others. So the user and group has read-write permissions, but others has only read and execute. So as a user called Bob, you can run the script. You can say /test script.sh. It works. These execute permissions are applicable for scripts and also binary programs. Even if you have a binary program, you want to run it, you need to have execute permissions to run that as a program. It's possible that I can remove execute permission from others by doing a O-X test script.sh, which means that, okay, I forgot to write chmod there. Okay, chmod O-X test script.sh. So when I now look up this file, you can see that earlier there was execute bit enabled for others, which is now being removed. So, but however, the user and group can still run it. So as a user, I can run the script. Alice can run it, but Bob maybe can read the script contents by doing a cat test script.sh, but he'll not be able to run it by doing a /test script.sh because no execute permissions are applicable for others. This is not a dead end actually for scripts. If you're already able to read the script, you know the script signature on top shows /bin/bash. That is the interpreter. Anyways, Bob can run it by typing /bin/bash /test script.sh to run it manually. The point is the script is not self-executable by this user. He has to use the script interpreter manually and run it. I don't think there's any good benefit of this feature, so it's there. Either you enable execute for all or don't enable them, right? That's how it is. So this is what the X indicates for a file. So when you have read permission for a file, you can open the file for reading and read its contents. If you have write permission to a file, you can overwrite the file. You can open the file for write mode, overwrite it, truncate it, or append new lines to the file. If you have execute permission to the file, you can execute it as a program, assuming it's got a proper script signature, or if it's a ELF format program binary, which is generated by the compiler build toolchain, right? So that's something that you should know about the permissions and how they apply to the file. But however, the same read, write, execute permissions work differently for a directory. So if you're working on a directory, so if at all I create a new directory here, but before I go to the directory, I'll try to talk about one more important thing. Then I will talk about the directory. You'll see the connection. So let me do one thing here. I'll say ls-l. Let me just remove all permissions from the file a.txt from group and others. I'll do a chmod go-rwx a.txt. Revoke all permissions from group and others. Now this particular file has only permissions for the user for performing read and write operation. So as a user called Alice, which is what this shell is running as, you can perform a read and write to this file. As a group and as others, no permissions are available. Obviously, the user called Bob falls in the others level of permissions. So if Bob tries to cat this file, he cannot see it. If Bob tries to, let's say, modify the file by doing a echo and some string greater than a.txt, when that is not allowed. So Bob user cannot do anything to this file content. He cannot really modify the file content, nor can he read the file content, right? But here's the thing. What if Bob does rm-f, forcefully delete a.txt? This user has no permissions on the file. No read, no write, no execute. But can he delete the file? What do you think your answer is? Well, most people think that you cannot delete the file. If you don't use a -f switch, it'll give you a warning. Remove write protected regular file a.txt. It's trying to tell you that, oh, you don't have any permissions on the file, so the file seems to be write protected. Do you really want to delete it? You can say yes. If you don't want this question, you can say rm-f. It'll not ask this question, it'll delete it. And the file is actually deleted. Let's verify. Let's verify even here to be double sure. The file is now gone. You should note that in order to delete a file, the permissions on the file do not matter. The permissions and ownership of the file does not matter to delete a file. Oh, that means that anybody can delete anyone's file, right? Not really. The reason why Bob was able to delete the file is because of the permissions of the directory. The current directory that is there here, the /temp/Alice, which I'm accessing as Bob, and that's where the file was created by Alice here. The permissions of the directory, if you just look at it, it's a world writable directory. What is a world writable directory? A directory where you have read, write, execute, read, write, execute, read, write, execute for user, group, others is a world writable directory. In order to create a new file or to delete an existing file in a directory, you need to have write permissions to the directory. Because Bob can have write permissions on directory as others. There's write permission on this directory. ls-ld lists the current directory contents, which is dot is this /temp/Alice. You can also look it up like this. You can say ls-ld or ls-l/temp. You can see that the folder called Alice is got read, write, execute, read, write, execute, read, write, execute. In fact, when you look at any world writable directories, it will be highlighted with a background green color on my desktop or my environment. You might have a different color depending on the distribution that you are using, but this is how world writable directories are signified. Which also means that when you have write permissions on a directory, a directory is owned by Alice, right? But Bob can go and create a file in it. So it's like you just open the doors to all your house, and you can just tell people, anybody can stay in my house. If you're going to allow anyone to stay in your house, anybody can walk in, they can use any room, they can also destroy stuff. That's the freedom that you're giving, right? So if it's free for all, it's definitely free for doing anything, right? That's exactly the case here. So as a user called Bob, you can go to the directory, and you can also create a file. I can say cat greater than, or maybe you can just use nano and say bob.txt here, and you can say this is Bob's file. So Bob ended up creating a file in folder owned by Alice, right? This is Bob's file. That's it. You can see that. And yes, Bob can also indicate that nobody else can access my file. I can do that by using chmod go-rwx bob.txt as Bob user. Bob is the owner of the file bob.txt, so Bob can change that file permissions. And the irony is, this file exists in a folder owned by Alice. So Alice is the owner of this folder, right? This folder is owned by Alice, as you can see here. This current directory. And there's a file inside it that's created by another user called Bob. Alice is not the owner of the file. And what is the domain? What is the level of permissions that's applicable to Alice? Obviously, others' permission, because the file is owned by Bob, is also owned by the group called Bob. And when it comes to Alice, He's never a member of that group, nor is he Bob. So obviously, the others level permissions apply. As user called Alice, he cannot look up Bob's files. It's like I let people to use my place freely, my house. But somebody just walked in and took over a room and locked it and said, this room is now owned by me and that person, and I can't access to it. I own the house, but I cannot access the room. I'm sure you know it if you're old enough to have children and you give them their own private room, they have their privacy. Right? That's how it works. That's how it is. And there's something we should know. This is applicable even to folder. It's possible that Bob can create a folder here which is owned by him and make sure that Alice cannot access his folder. It's possible to do that, right? And but the thing is, because this is a world writable directory now, Alice has full permissions to, he'll not be able to access Bob's file, but he can always delete it by using rm-f bob.txt. Oh, I can't read your file. You better not be here. And delete it. So this is possible. Because to delete a file, the permissions and ownership on the file does not matter. What really matters is the permissions that you have on the directory and maybe its ownership in certain cases. So that is something that you should know. Now coming to the permissions on a directory, this is how they work. For example, if Alice wants to restrict this directory completely. For now, let's assume that Bob was not in this folder. Bob can always change directory to Alice folder and access it, right? Let's see what happens next. Okay. So there are a couple of files here still. There's only one file. Let me touch a couple of files here. Touch a.txt, touch b.txt, and touch c.txt. I create a couple of files here. Okay. There are some files like A, B, and C, and test script. That is it. Now, if Alice does not want people to see what's in his folder or in her folder, right? So what Alice would do, chmod go -r dot is current directory. So Alice is changing the permission, not of the file, but of the directory. So before I run this, I run ls-ld here. You can see this is the permissions for the directory, the current directory. The moment I say chmod go -r, remove read permissions from group and others to the current directory. Now if you do ls-ld, you can see that user called Alice has read, write, execute permissions on the directory, and group and others, they have write and execute, but no read permission. And this is a useful feature. I'll explain where it is used in practice. Now, as user called Bob, they can enter this folder, but you cannot see what's inside it. You can see this ls command is showing permission denied. This is interesting, which means that you just walked into a dark room. If you already know what files might have existed from your earlier experiences, you can access that file. For example, if Bob sort of figured out that in early days before, I remember there was a file called testscript.sh. He knows the file name, he can cap that file. Like sometimes if you walk into your own room, your personal room, you know where all the things are kept around. It's properly organized. Sometimes if there's a power failure or something's wrong and your room is dark, there are no lights in your room, you can still try to manage to scrape through your room and find out stuff. Maybe find out a torchlight or to turn it on, an emergency lamp or something like that. You'll be able to reach out to it. You know where it's kept. If you know where it's kept, you'll go to the direction and search for it, and that's it. That's exactly how things work here. Now, the main purpose of having these kind of directories where you allow write permission for others, but no read permission, is for public upload folders in FTP servers, and maybe if you have a SH server. Let's assume that you're hosting an FTP site, a file transfer protocol server site, where many users can upload their files. But what files they upload, I can upload my file, but I can also see what file you uploaded. But you don't want to allow that. Everyone can only know the file they created or uploaded into this folder. So therefore, they can delete their files because they know the name. But for others' files, I'll not be able to guess it. If there's somebody else who logged into the same machine and maybe as user called Ben or James or anybody else, and they created a file. I'll not know what file is created by others because I can't see them. There's no other way to know until that user tells me, right? So until that user discloses and tells me that I created a file with this name, I will not know it. I'll not be able to discover it on my own. So there's no possible way to delete it, right? So if Bob has created a file, let's say by doing I could just use touch. I'll use touch over here, touch, and say bob.txt here. I know I created a file. The file is there, but I can't see it. But I know I created it because I know the name. But I can't see where the file is by running ls command. It's like throwing something in a dark room, right? Because Alice can now see there's a bob.txt, because Alice as a user has read permissions on that directory. You can see the contents. But as Bob, because I created the file, I can also delete it. If I know what the file is, I can still delete it, or I can edit it. The file is vanished. You can see that right here. As a user called Alice. This is the use case. So in summary, if you want to see the contents of a directory, you at least need read permissions on that directory. Only when you have read permission, you can run ls command, commands like ls to see what's inside the directory. That's the significance of read permission. If you write permission in a directory, you can create files or subfolders in the directory. You can also delete files and subfolders in that directory. It doesn't matter who owns it. You can still delete it because you have write permissions. So having write permissions to a directory allows you to modify the directory by adding new links or removing links from a directory. Just like link and unlink operations require write permissions for a directory. And what about the execute permission? See, execute means it's for a program binary, right? But you can see every folder that you create by default will have execute permissions enabled. All these folders have execute permissions here. What if I remove execute permission? I will show you what happens. I'll just exit this folder for now. Okay. And now let me add the read permission. I'll do a chmod plus R. The plus R is like add read for all, right? Dot. We'll say ls minus ld. You can see now we have read, write, execute for user group others for the current directory, that is /temp/alice. What I'll do is I'm just going to remove execute permission from others. Bob falls in domain called others, level called others here. So I'm just going to use chmod o minus x dot. Remember, I removed execute permission from a directory. There's read, write, but no execute. As a user called Bob, here's what the problem is. cd alice will not work. So Bob cannot change to Alice directory. He cannot traverse that directory. It's called file traversal or directory traversal. He cannot traverse the directory. Now, right now, Bob can see that this folder exists. If he runs ls/alice, he might vaguely see that these files exist. You can see ls command is able to list all the files inside here. All these files are listed here, right? All these files are shown. It shows some access permission denied because ls tries to get some stat information. That's where it fails, but you can see the files inside it. But he cannot access them. He cannot read those files also, because if you do a cat alice/testscript.sh, doesn't work. Think of it like this particular folder is like an island. Okay, this Alice is now like an island. Earlier, we had a bridge to travel to the island, a bridge through which you can travel to the island. Now the bridge is cut off. You can see that island exists. You can see what's inside the island from the faraway distance. You can see, oh, that island's there. You can access all these things. You can see all those things in the island, but you cannot really access them. You cannot read them. You cannot reach to the island. So it's like a bridge that's being cut off. That's exactly what execute permission removal does on a directory. So if at all you want to traverse a directory, that's you want to use it in a path, like, if you have a file in a folder and this folder / this folder, this folder, if you want to traverse that folder paths to reach a file, for the traversal access, execute permission is crucial. You don't have execute permission for a directory, you cannot traverse to the directory. So even if you have read and write permissions, it will not really be useful. I'll try to create a file here that also will fail. So try to do a echo and some string, or maybe I'll use touch command. I'll use touch and alice slash v2.txt. Doesn't work. Because in order to create a file, you have to traverse the directory to create a file. The directory traversal is completely stopped because the execute permission is removed from the directory for others. So now you know what execute permission does to a directory, right? It cuts off the bridge that connects you to the directory. So there's no way you can create a file in a directory. You cannot read a file from the directory. You cannot modify a file in the directory. Can I remove it? You can also not remove it, because for removal also you need to traverse the directory. So say b2, if I say alice slash a.txt over here, that's what. So in summary, you have seen, if you just remove execute permission from a directory for a level like others or group, for example, you're cutting off the others or the group members from the directory completely. Completely. They'll not be able to change to the directory. They cannot use a directory in formulating the path to reach to a file, because that acts like a bridge. You're cutting off the bridge completely. So this makes your directory completely quarantined from others' access. Right? So this is how permissions work for a directory. To summarize, in order to see what's inside a directory by using commands like ls, you need read permission. In order to create or delete files in a directory, you need write permission for a directory. In order to traverse a directory or change directory or use a directory in your path to access file through the directory, you need execute permissions on the directory. So this is how the read, write, execute apply to a directory on all Unixes, including Linux. The last one I should talk about is the use of sticky bit. The sticky bit has no use case or no use for binary programs anymore, but it has a special meaning for a directory. If you observe that if I had made this directory world writable, so this now I'll just use chmod 777 dot, it's easy, enable all permissions to the current directory. So everyone can read, everyone can write, everyone can execute, right? So the directory is got full access to everyone. When this happens, if Alice creates any file in here, let's say a.txt, right? I would log in as Alice and in here, and I've created some files as Alice. Let's say Bob also creates a file here. Let's say Bob, let's say does a touch bob.txt. Oh, I'll go to slash, okay, Alice folder. I'll go to Alice folder, and here I'll do a touch bob.txt. So as Bob, I created a file here, bob.txt. Let me show one more user here. I'll try to use another user. For that, I'll open up another terminal. I'll open up another tab. I think it's easier to do it like this on my machine. Bring this tab to a separate window. Okay, it went to another screen, sorry. Let me bring this in here. Let me keep this in here. And let me log in as another user. You know, the trick I'm using for using different user accounts in Windows subsystem for Linux is, by default, when you install Ubuntu, it'll just install with one user, whatever username you selected when you install WSL. If you want to add new users, you can always use sudo user add -m and username. This is how you can add a new user account. And then you can also use sudo passwd and the username to set a password. So if you say sudo user add -m, I'll also add a description. Let me just add a user called Alan K. Alan/prod.com. You don't know who is Alan K. He is the pioneer in the object-oriented programming concept, and also he is the one who invented the graphical user interface. He's still alive. He's part of Apple, so he works at Apple at this moment. Anyways, so I'm just devoting his name here. Anyways, I'll just say user add -c, Alan K, Alan@/prod.com, and Alan here. This creates a new user account. Okay, because I'm using sudo, it'll ask me for the password as Chandra, because these are all privileged applications like user add. You have to elevate your privileges to run this. I covered that earlier. I'll type the password. User is added. In order to allow this user to be logged in, you need to do a sudo pswd and the username, Alan. I'll set a simple password here. Welcome. Now to switch as to that user, I can do a sudo su minus and Alan. The minus switch will launch a login shell. After that, if you give a username, rather than becoming root user, it will switch privileges to that particular user. Cross over to that user. I think the default shell is configured not as bash, but as hush. That's a shell that's there in Ubuntu. I'm not sure why it is using that, but I will change the shell also, chsh. And Alan's password is this. The default shell, I want to make it a /bin/bash. Log out, log in again. Now I'm logged in as Alan. It's ID. The user name is Alan. Now let's say that Alan also goes to /temp/alice folder. And Alan also creates a file, touch alan.txt. Now there are many files. There are different users. There's a file created by Alice, there's a file created by Alan, there's a file created by Bob. Now the problem here is that anyone can delete anyone's file. Because this folder where I created the file, everyone has write access. This Alan and Bob fall in others level, and others have write access to this directory, as you can see here, right? Read and execute. So therefore, it's possible that Alan will not just create his own file. Alan can find Bob a little annoying and kill delete Bob's file. So I can just do a rm bob.txt and the file is deleted. Likewise, Bob gets a little more annoyed. Oh, my file is deleted. I'm going to delete your file. I figure out that Alan deletes a file. He sees Alan's created a file. Okay, let me go and delete this. And Bob then wonders, oh, who deleted the file? Is it Alan? Is it Alice? I'll delete every file over here. I can just say rm a.txt. Delete Alice files too. One user can delete another user's file because everyone has write access. This is generally not good, right? Because if you're giving world write access, how do you ensure that a user does not end up deleting others' files? This is where you use the sticky bit. If you enable the sticky bit to a folder, I'll show it as Alice over here. To do that, you can use chmod +t dot. To enable the sticky bit to a folder, it's actually not called sticky bit for a folder, it's called something else. Called owner delete only, whatever. Some people have termed this right now, but it's a T to indicate sticky bit. So there's an owner delete only. That means that if you see a small t at the end for a folder, that means the sticky bit is turned on a folder. What this really means is, from now on, anyone can create file here as usual. Like Bob can create a file in this folder. I'll do it as Bob user here in this terminal. Let me clear the screen if it looks a little cluttered. As user called Bob, in this temps Alice, I can create a file. I'll just do a touch bob.txt here. Oh, bob.txt. B. So this file is owned by Bob, bob.txt. Likewise, Alan can create a file too in this folder. So Alan calls touch alan.txt. All these files are empty files. Just showing you a demo here, right? So there's another file called alan.txt which is created by Alan. But here's the thing. The user can create a file, but he can only delete his files or her files, the ownership files, right? You must be an owner to delete the file. You cannot delete somebody else's file. For example, Alan cannot delete files owned by Bob. For example, you cannot do a rm-f bob.txt. That won't work. So does Bob. So Bob cannot delete Alan's files. Bob cannot delete, files owned by Alice. Let's say b.txt here. Reports operation not permitted, which means that Bob can delete only files that is owned by this user, Bob. So you can just do a rm bob.txt and this will work. Likewise, Alan cannot create any other files apart from the files created by this user, then, right? So say rm alan.txt. You can delete your own files, but you cannot delete others' files. You cannot, let's say, do a rm-f b.txt force delete, right? Doesn't work. So if you end up creating a world writable directory, a directory which you're giving access for everyone to store their files or create their own folders. As a safety measure, you generally enable the sticky bit on such folders to ensure that one user does not delete another user's files or folders. This is very crucial, especially for one of the folder where this is enabled. You just do a ls-l slash. You observe that the temp folder is by default world writable. That's where Alice was able to create a file, Bob was able to create a file, and all that. So temp is a world writable directory, and this directory has a sticky bit enabled for safety reasons. You should note that it's not just human users creating files. Many programs running as services in the background, they can also create some temp files. When services create their own temp files, it shouldn't be a case where you have a malicious service that goes and deletes temp files created by other services, making sure that those services collapse. Some Trojan services can do that. So this safety measure will avoid that kind of a scenario. So it adds a bit of safety. Only owners can delete files in a folder which has the sticky bit enabled. All right. So I told you the different permissions, the standard permissions, how they are applicable to files and folders. And that's pretty much it that you should know for basic permissions and in the DAC model. There are more security models available on Linux. For example, if DAC doesn't really cut in, you can use the mandatory access control. Unfortunately, the Mac model is not very in widespread usage today because it has a severe performance impact and it's an administration headache for most administrators. And it is also very, very file system dependent. Very few file systems on Linux support Mac security. This Mac, also called as mandatory access control, allows you to create ACLs where you can say one user what permissions he has, second user what permissions he has. You can have different permissions for different users. When you're setting permissions using DAC, there are only three kinds of permissions you can set. Permission for the owner, permission for the group, permission for others. What you cannot do with your chmod command is, I want to add read permission for Alice, I want to add read and write permission for Bob, but I want to provide read, write, execute permission for, let's say, Alan, and then only read permission for another user. You cannot do user-specific permissions. That is not possible with the discretionary access control security model. But this is fast because the rules for security is just 3 levels. So the rule checks are only 3 levels. Unlike the ACLs, which are used in Mac, where every time you want to access a file, you have to go through an ACL list and verify what rules apply to a given user, what domain he or she falls into, and must be applied. So for that reason, it is not used widespread. It's used widespread in the practical deployments of Linux, right? Very rarely Mac and ACLs are used. But however, there are more sophisticated security models available on Linux, which go into a category called Linux security modules, shortly known as LSMs. And they provide more complex policy-based security, which is not just going to be with files, but with even system calls and other resources like sockets and namespaces and so on. And there are different kinds of LSMs available for different use cases. And the most prominent of them used on server-grade environments today is SC Linux, promoted heavily by Red Hat and their partners. There's also another contender for SC Linux on the server market is AppArmor, which is being spearheaded and by SUSE Linux and Ubuntu. Canonical and Micro Focus work on it. And there are also other more lightweight policy-based security models, which is called as MAC, which is used on embedded boards and appliances primarily, but people are now using it for regular systems on Linux. And there are many more which are there, but that's a topic that I will focus when I talk about it in a separate training course on Linux security, right? For now, standard Linuxes, this is what works. You have to just learn this, and they should be sufficient for majority of the use cases. Okay, so with this, I end this video. Thank you very much. I'll meet you in the next one.